in the previous lecture, we talked about the fundamental theorem of fembiology and the proof that surrounds it, that reinforces this notion that the integral from twink trap of the human function of h dh is equal to the femboid. That was the fundamental theorem of fembiology. In this lesson, I'm going to be discussing about measures of homosexual tendencies. Lecture 8. Mesh of home tendencies. And to begin, let mu bar denote the measure of homosexuality. So this guy can be measured in percent or in decimal form. It could be percent or in decimal form, which is a fraction, expresses a fraction. So what mu bar tells us is basically how gay the person is, right? That's basically what we're describing with this mu. We're basically describing how gay that person is. It's measured percentage. And before we actually dive into it, I need to tell you guys first that if this is an element, if mu is an element, then of two sets, or the intersection rather of two sets, then mu bar is an element of the Bussy set between those two sets. Okay, so if mu is part of the intersection of two sets, then there exists a Bussy set for those two sets where mu is a part. Now, to prove this, consider that one of the sets is the set of all things male, and S sub 2 is all things female or girl. So now we know that we know from the definition of a Bussy set that A is if we have an element that's a part of M, that's a part of the intersection of M and F, then A is part of the Bussy set. We could have ended the proof there, but I want to say further that both males and females have the ability to possess homosexual tendencies or be attracted to the like gender. That is, mu is an element. Mu is an element of M, and mu bar is an element of F. And so, through that, mu bar is an element of the intersection between M and F, and that proves it. Mu bar is an element of the Bussy set. Quadra demonstratum, box to end the proof. So, what do we do with this? How do we define this equation? And mu is not only just a quantity or variable actually, but it can be a function as well. If we let mu be a function of a percentage, then we can branch it out into a piecewise function. And a piecewise function is basically just a function that contains sub-functions, little tiny functions, like a family of functions. So to define M, if P is less than 50%, this is an acute homosexual, or P is less than 50%. And it is a balanced homosexual, for P is equal to 50%. And lastly, obtuse homosexual, for P is greater than 50%. Right? And a special case of this function is when P is equal to 100%. And that 100% is called an absolute homosexual. So a very, very gay person cannot convince him to not be gay. Absolute homosexual. absolute. And another special case is when P is equal to 0%, where this is called a null homosexual. Either a null homosexual can be a straight person, it can be a bigender, it can be a bisexual, actually can be bisexual, but a bisexual actually can be described as balanced or 50% gay, or actually it could be an asexual person or a straight person, because a straight person has zero gay tendencies and thus is 0% gay. Alright, so now that we have inversed the function type of things, if we assume that M or mu bar, if we assume that mu bar is a space, a vector space, just a space or a manifold, and the percentage P is another manifold, then this relation holds. Mu hat maps the small percentages onto P. So mu here is a function of P. We're basically saying that mu hat is a function of P. It's a function of small p through mu hat. So the measure here determines which percentage these guys belong to, or which label these percentages belong to. So if we have random attributes here, or percentages, or mu's, or measures actually, if this is the space for mu, then, or actually small p, space for small p, then mu hat maps each of these points onto a small one by one space, where most of the probabilities or the percentages stay within 1, because we can't go beyond 100%. P cannot exceed 100%, or in decimal form, P cannot exceed 1. And likewise, sums of P must be less than 1. So if we have various percentages, their sum must not be greater than 1. And I've only discussed about percentage notation. What if we want decimal notation? So going back a while ago, mu bar is equal to the piecewise function. Acute for P is less than 1/2 for decimal. Balanced for P is equal to 1/2, and obtuse for P is greater than 1/2. And absolute homosexual for P is equal to 1, and null homosexual for P is equal to 0. That's that. So you should say the maps a while ago, if we describe M as a space and capital P as another space, or actually small p as a space, capital P as a space, mu hat maps every corresponding label onto their corresponding percentages based on what they are. Alright, and now if we want to hit reverse and say that mu is a inverse function, we're going to assume, for simplicity, that for mu hat P, small p, maps small p onto big P, there exists a mu hat -1 which maps big P onto small p. So it just does the other way around. So if you have these two guys, two axes, if this over here is mu hat, this over here is mu hat to the -1, the inverse. And you guys are probably asking about probabilities of being one of these guys, and the probability is 1/5 or 20%, and that's relatively easy. You can just say some initial conditions may affect the probabilities stated. One notable example of an initial condition is the exposure to queer promoted material. So if we're giving an initial condition here, like to say the person's exposed to it's okay to be gay, and then of course their percentage may spike. So now I want to apply some statistics onto more or less. So if we have a population size or amount of homosexual specimen n, and consider they have a mean homosexual measure, mu hat mu, because mu is a notation for the mean, or just the middle, basically, that's what we're saying, in a given standard deviation sigma. Sorry if my sigma looks ugly. Then, now, if we have a certain quality or certain measure that we want to find the probability that a part of these guys are, or percentage of these guys are part of this, or actually, if we let x bar denote a quality that the population or part of that sample size may contain, then the probability, the probability that p, if we let p hat be a certain thing, a certain percentage of this population that contains this, the probability that p is equal to this is equal to the probability that z is equal to that, where z is equal to x bar minus mu bar subscript mu over sigma over the square root third of f. Z, or this one here, probability of z equals x bar is found by interpolation in the cumulative z table. You guys can search that out. And so I suppose I'm gonna give you guys a thing for this. I'm not gonna provide an example for this because I already have an example. Because that you can, if you want to find probabilities that a portion of this contains this quality x bar, which is this p hat, then we can find probability that p is equal to this, or they have this, via the cumulative z table, which is z. And this is all called, in statistics, this is all called a sample distribution. Right? So that's it for this lecture. In the next lecture, I will be talking about a brief study into flamboyant apparel, basically thigh-highs, skirts, hoodies, you name it, I'll discuss it. And that's for the next lecture. After that, we're going to be discussing yaoi, voice, in depth, and maybe an introduction into theoretical medicine, Omegaverse. And I just want to say that a brief study from Boca Apparel is also sort of an introduction into appearance engineering, which I will also be discussing. And after we will be discussing a small modeling of trap behavior, so using these guys. These are called kept vectors, and we're going to use those to model trap behavior in lecture 11. And after that, we will conclude this course by discussing an existential paradox, which is the transgender family. Now, the reason why I even made or discussed the fundamental axiom of femboyology is because we were avoiding the discussion of these guys. But now that we have gained a deeper understanding of what the femboy is and went in depth on what they are, we can finally tackle these guys. And in that last lecture, we will be given a choice. But don't stress that. Just think about your assignments for now if you're enrolled in this course, or just review this and prepare for your midterm exams. So that's actually it for this lecture. I'll see you guys in the next lecture. Actually, just to tell you guys, I'm already beginning to lecture my Regicalculus course, or chapter differential equations, and it's all there in the second folder playlist I gave, and I've already started my lectures on starting with notation. So check that out if you guys want to enroll in that course, and it might actually be required if you're going for a BUSI major in this institute. You may need to take a couple courses, including that course, if you want to attain a BUSI major. So, see you guys in the next lecture.